All right, so we are now being recorded. So again, welcome all to the sixth video teleconference for BIOL 104 YC. Um, we have several agenda in this video teleconference. First will be to look at our calendar ahead. What are we expecting ahead? Second will be, I believe we really need to discuss some of the items from problem sets, especially problem set number 4, the deadline of which is later at 12 midnight. So don't expect that we will discuss all the answers. In fact, I will only discuss some concepts, based on the problems that might give you a hint if you haven't gotten it yet, no? But I assume a majority of you, or maybe all of you, have already understood the concepts from the problems. But if you didn't, um, we are going to try to address that in this video teleconference. And lastly, announcements as well with regards to quizzes and midterms and deadlines. Right, so this is our calendar. We are now in the second week of February. There are no classes, of course, on Friday. We don't need to worry about that because we don't have a class on Friday. We are currently now on time with our video teleconference number 6. If you can remember, last week we did it on a Saturday, but now we are back on track. And this week we are supposed to be learning about Chapter 4, continuation on modifications of Mendelian ratios. And a new problem set 5 has just been provided for you. And that's the last problem set before the midterms. The midterm exam, although in the course wall, it was written there, um, it's gonna be given this 20th. I'm reconsidering of giving it to you on the last week of February instead, no? Sometime siguro mga February 24, no, on a Wednesday. Um, the coverage of the midterm exam will be chapters 3 and 4. They are quite challenging, perhaps for some of you, because there are problem solving and that relates to probability. So you really need to practice. And in this video teleconference right now, we are going to address problem set number 4. Okay, so these are the things that we've done so far. Coverage for the midterm will be 3 and 4. So right now we will begin our understanding. We'll try to understand problem set number 4. Okay, so I hope you will also be able to give feedback or contribute in the discussion, so that it will be more dynamic. And you will learn better if you actually contribute to the discussion. So let's start. As promised, I will not be giving you all of the answers, but some of the answers I might. So since the deadline for this is still 12 midnight today, you might still want to modify some of your answers after this video teleconference. All right, so let's start. In radish, the effect of the alleles producing the long red variety is incompletely dominant over the effect of the alleles producing the white round variety. The heterozygote will be purple and oval. So from question letter A, what phenotypic and genotypic ratios would you expect in a cross between, we will only answer red long crossed with white round. Okay. Now, before we can answer this, we have to understand first what is incompletely dominant and what traits are we talking about here. Okay, anyone from the group? How many characters are we talking about here in number 1? Are we talking about one, two, three, four?
4, sir.
Four, sir.
Four characters. All right. Are there any other answers?
Two, sir.
Two characters. Okay. Can you explain why two?
Because it has something to do with the color and the shape, sir.
All right. So do not count all four because those are alleles. Okay. So when we say character, that's the one dictated by the gene for either the shape or the color. So there are only two characters here, guys. So in other words, we are sort of doing a dihybrid cross here, no? Similar to a dihybrid cross na dalawang characters ang tinatrack natin. So, for the sake of simplicity, we're gonna use the letter C for color, okay? And of course, the allele comes in pairs, so you have a C and a C. Sorry, let me change the size of this second C. So you have a C and a C for color, okay? And then for shape, maybe we can have an S and an S, okay, for the shape. So this is how the genotype would look like. You have here the alleles for color, and you have here the alleles for the shape. Okay. Now take note that we have certain traits. Now, if we talk about traits, we are talking about four traits. Okay. We have white, red. Okay. And then we have long, we have round. Actually, we have five or six. Then we have purple, and then we have oval. So those are the traits. Okay. So let's see what information is given here. Red and long are incompletely dominant over white and round variety. So we have red long and white round as the true breeding. Okay, so meaning to say, if this C and C would be R and R, this one will be a red colored radish. No, R and R. And if our S and S here will be L and L, this will be a red and a long radish. So if we are going to represent our white and round, sorry, white and round, how will that look like in terms of letters? Anyone? For the colors,
Small r and small r, sir.
take note of the term incompletely dominant. We refrain from using capital and small letters when we are representing incomplete or codominant uh, alleles.
1, sir. W dayon RR.
All right. So you may use another letter, no? So we can put W for white, white, and then for the shape, round and round. So this one will be white colored and round at the same time. Now, there is also another variety here, a purple oval. How will a purple oval look like in terms of genotype? So we have our CC and our SS ready here. How will a purple oval look like? Um, a purple oval is a result of a heterozygote. What does that mean? A dihybrid.
May
Go.
an mahimo siya og RW dayon LR.
Yes. So dihybrid, meaning to say for the character of color, it's a hybrid. It's a combination of an red and a white allele. No, that's a hybrid for the color. In terms of the shape, it's also a hybrid. So that has both long and a round allele. So this one is your purple and oval. So if we try to answer the first portion here, okay, red long. So I think we have the parents here on top. Red long crossed with a white round. What will be the genotypes?
All will be purple, sir.
Yes,
Um,
all were, you're correct.
RW and LRs.
All right. So take note, one of the parents are R lang lahat, and the other parent WW lang lahat in terms of color. So they can only contribute those alleles. So therefore, the offspring should be similar to what we have here. Okay, this one. A combination of R and W for color, okay, and then L for R for shape. And this is going to be purple oval. So phenotypic ratio will be all or 1 over 1, no, purple oval. And genotypic ratio would also be 1 over 1 CR, CW, SL, SR. Okay, so you figure out for the other items because we are not yet done, no, with, in terms of submission in this problem. So I hope that gives light for some of you, know, who are still figuring this out. Next, any
Sir,
questions?
question,
Yes.
sir. It's okay to use numbers, sir, right? Like example for red is R1, R1. For example, for red long is R1, R1, and L1, L1. It's okay, sir, no?
Yes, yes,
Okay.
that's okay. As long
Okay.
as we avoid the same symbolism for dominant and recessive na capital
Uh,
and small letters.
okay, sir. Thank you, sir.
Right, next. Problem number 2. Okay, when a white guinea pig is crossed with a yellow guinea pig, all the progeny or offspring are cream colored. So you see here already that the progeny is differently colored from either of the parents. Okay, from a cross of such F1s, the F2 will show 32 white, 66 cream. So one half will look like the F1, one half of the F2s, and one fourth will be white and one fourth will be yellow. So let's try to answer letter A only. Letter A muna, okay? How is this trait inherited? When the offspring doesn't look like either of the parents. And in the F2, one half will look like the F1. Anyone from the group? If you have answered this already, then maybe you can just say your answer. When we say how is this trait inherited, is this complete dominance? Is this codominance? Is this incomplete dominance? Is this multiple alleles? Okay, that's those answers.
Incomplete dominance, sir.
Incomplete, sir.
All right, we have two answers, not two people who answered incomplete dominance, and you are correct. Now, so for example, we can symbolize white guinea pig, that white color will be WW, okay? And then we cross it with a yellow colored guinea pig, that's YY, resulting to WY, of course. And WY will be, um, because of incomplete dominance, the result here will be different color from either of white or yellow here. So it's cream. So you are correct. This is incomplete dominance. We will not answer letter B. Okay, next. Coat color patterns in cats may be full, silver, or Siamese. Okay. Give a complete genetic explanation of these results. Unfortunately, I will not be discussing that in detail, but here's a hint. The one that I checked here, Siamese. If you cross a Siamese with a Siamese, the result will always be a Siamese. Meaning to say it's true breeding. Okay? But somehow, Siamese will appear if you cross full and full. That's possible. Or if you cross silver and silver. So, what does this tell you about the color Siamese? What are its alleles? If you've actually read the book, there is a very similar problem to this um, in one of the problems now presented in the book. So I would like to hear your answers, perhaps. Don't worry. If you tell me the wrong answer, I will say it's the wrong answer. So you would already know that that's not the answer for your seat work, no, for your homework. Okay, anyone? What explains this? Specifically the Siamese color or pattern. Take note when you cross full and full, all of the patterns would possibly come out. Full silver and then Siamese. But if you cross silver and silver, now we are down to two possibilities only, either silver or Siamese. You see that? Wala nang full. Full is not possible. No, pag silver and silver. And then Siamese and Siamese, now we're down to just one possibility, Siamese. So what's happening here? Is this complete dominance, incomplete dominance? Is this multiple alleles, co-dominance? Choose between those. What do you think?
Codominance, sir.
Co-dominance. Okay. If this were co-dominance, let me see. What made you say it's co-dominance? I'll ask you. Di ba pag co-dominance, for example, co-dominance, full and full. Di ba? Hindi naman pwede kasing full and then silver because they will be co-dominance, meaning to say they will mix. Okay? Or, you said co-dominance, no? So um, they will sort of show each characteristic distinctly. So let's try that. Full and full. How do you propose the other one will be? Pag co-dominance. Still F and F. Now, how is it possible you get a silver here? How is it possible you get a Siamese here? If this were co-dominance. Then again, let's focus on the Siamese color here or pattern. Kasi it's the simplest one to analyze. Eh. No, it's the simplest one. Um, it somehow is masked Okay, I'm already saying the important terms here in the full times full because it appears as an offspring, but it's masked here in the parents. In silver times silver, it's also masked by the silver because it appears in the offspring, but it doesn't appear in the parents. But if you cross a Siamese parent with a Siamese parent, it's a true breeding, only Siamese is a possibility. So ano na ito? Siamese gets masked by full, gets masked by silver. But Siamese will appear. What does this remind you of?
Multiple alleles, sir.
All right, that's half of the answer. We have multiple alleles here. Specifically, how many? One, two, three, four. How many? So someone said it's multiple alleles. That's correct. How many? Or let me ask another question. Okay, back to what I said a while ago. Siamese gets masked by full, gets masked by silver. Okay? But look at this. Silver also gets masked by full. Okay, very exciting. And then Siamese will only be able to express itself wholly if the parents are both Siamese. Okay, you get this now? Siamese will only be able to express fully if both the parents are really Siamese also. Siamese gets masked by silver, Siamese gets masked by full. And silver, as I just mentioned, look at this, it appears here in the first cross as an offspring, but it's not present in the parents, it gets masked by the full. So what is this? How many alleles? Correct multiple alleles, how many? Okay, I'll try to direct you para diretso tayo sa answer. Okay, because I want you to figure this out, no? Okay. If we are going to assume it's multiple alleles, and let's assume there's an allele for full, there's an allele for silver, and then there's an allele for Siamese. Siamese, silver, Siamese. Okay. If we assume that, do you think we are one step closer to the answer? Multiple alleles, there's an allele for full, there's an allele for silver, there's an allele for Siamese. Okay, answer so that we won't spend time in this number. I'm planning to discuss the others pa.
So there's three alleles, sir.
You're not quite sure with three? Now, my question a while ago is if we assume three alleles like the one we have here, F, Sil, and Sia, are we closer to the answer? That's just my question. Yes or no? Come on, anyone answer so that We'll move forward.
Medyo close na, sir, pero dili gyapon kulangan pa siya.
But we are closer. I agree with you. Okay, so check natin yan. Okay, now, if indeed these are the alleles, it's time to decide on dominance. On dominance. And based on what I talked extensively a while ago, Siamese is masked by full, masked by silver, but it can only express itself if both of the parents are Siamese. What can we say about the dominance or the recessiveness of Siamese allele? Is it the most dominant, the middle dominant, or the most recessive?
Most recessive.
Most recessive. Correct. Most recessive. So what is the most dominant? The one that masks all of the other two.
Full, sir.
That is correct. So if we can use the greater hand, lesser, lesser than symbols, we have these in terms of dominance. So in other words, we can now sort of answer this last one, Siamese, Siamese, no? And because we've decided that this is the dominance, we can simply use capital S for silver, and we'll now use what? Because Siamese is recessive to both, just like type O is recessive to A and B, we can use a small letter S. Okay, to make it easier for us. So if we have the Siamese times Siamese cross, because Siamese is recessive, it cannot be paired with another and still appear as Siamese. This must be small s crossed with small s to produce also all small s. Okay? So we have now figured out Siamese, and I'll leave to you how to figure out the other crosses. Full times full and silver times silver, considering the offspring that have resulted here. All right? So are there any questions? Of course, you may follow this in terms of maybe you're deciding to tweak your answers a bit. You can follow this. Okay, but you figure out the rest. All right, let's move on. Question number 4. This one is a bit simpler. Okay, ABO system. We know that AB are co-dominant to each other, while O is recessive to both type A and type B, no, na alleles. MN, we know that from the book. If you've read your book, M and N are co-dominant. And RH positive is dominant over RH negative. All right. So here we have to figure out who is the father of a specific child, and we'll just figure out child W. Okay, let's figure out child W. The information here says the mother is what blood type? ABO or AB? Mother, the woman. Mother. What is the blood type of the mother? A, B, O, AB.
Oh, I think, sir.
Oh, sir.
All right. Let's see. Take note here the anti-A and anti-B reaction. Okay, I think this needs to be clarified, no? When we say anti-A, it's sort of a chemical put in your blood. And if you have A antigen in your blood is going to have a positive reaction. No? Kasi anti-A is a chemical used to test. Anti-B is also the same. If you're type B and an anti-B is placed on your blood will agglutinate. It will react. No? So these are anti-sera, no, as written here, or anti-serum. By you're familiar with the term serum from our SDS page. Okay. So this woman, apparently her blood doesn't react to anti-A, meaning to say she lacks the A antigen. And her blood also doesn't react to anti-B, meaning to say she lacks the B antigen. So if you lack both A and B antigens, you must be a type O. You are correct. What about in terms of MN? What is the blood type of the mother? M and N are codominant.
MN po, sir.
Okay, so you notice here, the mother's blood reacts to an anti-M, meaning to say she has an M antigen, and her blood reacts to anti-N, meaning to say she also has the N antigen, antigen. So she is type O and MN because these are different systems of blood types. And of course, look at her RH reaction. It's positive. Okay, so meaning to say, because RH is simple dominance recessive, she could either be a capital, let's just say capital R, or a capital R, small r. So that could be the mother. Right. Now, let's look at child W. Child W. In terms of ABO system, what is the type of the child's blood?
A, sir.
Type A, yes. Okay, so type A ang child. In terms of MN system, what is the type of the child's blood?
Type M, sir.
Type M only, okay? So meaning to say, the child's alleles would be MM, right? Okay, those will be the alleles. In terms of RH,
Positive, sir.
okay, so the child can either be a capital R, or small r. In terms of type A, the child could be an AO or an AA. Okay, so take note of that. While the mother can only be an OO. Okay, so let's figure out who's the father, man A or man B. So let's do that the one at a time. Let's start first with the ABO system. Man A is type A. So is it possible for man A to pair with the mother and get a type A child? Yes or no?
Yes.
Yes, okay. Let's look at man B. Man B is type AB. So is it possible for man B to pair with the mother and come up with a child with a type A blood?
Type A? Yes.
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 Yes. Correct. Because man B could give the allele of type A, no, as a donation from his sperm, and woman or mother can give just an O. So it can be an A and an O together producing this AO child W. So it's possible. So in terms of AB system, we don't know yet. So let's look at the MN system. Okay. Man A is N. Is it possible for man A to pair with the mother na MN and come up with an MM, child W?
I think no.
Okay, because man A is type N, meaning to say NN lang yung sa kanya. And if you pair NN with MN, okay, mother could give the M, but what can the father give but just an N? And the child is an MM. So therefore, man A is not the father of child W, and it's man B who is the father of child W. So man B. All right. And then these are the blood types that we have here. So that's just an example, and you can include that in your answers later on. And you figure out child X, Y, and Z for yourselves. Any questions? All right, let's continue. Okay, number 5. Thalassemia, a disease in man which results in anemia, is controlled by a dominant allele, a dominant gene, capital N. Homozygous individuals have thalassemia majors. So this one will be thalassemia major, and they die. So let's put a cross in childhood. While heterozygotes, capital N, small n, will have thalassemia minor, okay? And normal individuals will be homozygous recessives. So I hope you figured that out, no? So a man and a woman with thalassemia minor, meaning to say, okay, both are heterozygotes with blood type AB and O respectively. So the man is AB and the woman will be OO. Okay, so this is the man and then this is the woman. They're gonna be crossed. They married and they had 4 children. Okay, so question letter A. What is the phenotypic proportion expected of their children that would reach adulthood? Okay, so in question A, do we need to look at the blood type? Yes or no?
No, no, sir.
No, because it doesn't matter. No. So what dictates if the child reaches adulthood or not?
The presence of
Presence.
thalassemia major, sir.
Oh, so both of you, I think, are about to answer that one. You're correct. So we all will only look at the capital N, small n for both. So what is the phenotypic proportion, no? Expected in their children that would reach adulthood? So who will reach adulthood? Just either of these two. Okay. And this is sort of a monohybrid cross, if you can remember. Okay. And in a monohybrid cross, do you remember the ratios in a monohybrid cross? What small n, small n? Monohybrid.
1/4, sir.
1/4 ang small n, small n. What about big N, small n?
1/2, sir.
1/2 or 2/4. And this one, dead, is of course 1/4, the remaining 1/4. So which one will survive? These two. So what's the proportion? You simply add these and you'll come up with, what's the answer?
3/4, sir, will survive.
3/4 will survive. Now, regardless of the blood type. That's the answer in letter A. And you figure out B and C for yourselves. All right, next, number 6. The gene for nystagmus, a condition characterized by involuntary rolling of the eyeballs, is X-linked recessive. Okay, so meaning to say it's found in the X chromosome and it is recessive. So we'll just symbolize that with small n. And shows partial dominance. 3 phenotypes are possible. You could either be normal, slight rolling, and severe rolling. No, so remember it is X-linked and it's recessive. Okay. The first thing that I want us to analyze here will be what's the difference between males and females. We know for males that our sex chromosomes would be a pair of X and Y, no? And for females, it will be an X and another X. So, let's categorize this into normal. We have the normal column. We have the slight rolling column, slight. And then we have the severe column. Okay, what combination of sex chromosomes will a male na normal possibly have? Of course, there's a Y. There's always a Y, guys, for males. There's always a Y. So, pag normal si male, what is the allele in the X? Capital N, small n.
Small n, sir.
Remember, if you have a
Capital.
small n, nothing will combat that, nothing will pair with that. It's just a Y. So you will end up severe. So it's not small n. So what is it?
Capital N, sir.
Dapat, if you're a
Capital N.
male, dapat may isa kang X na may capital N na allele, no, for nystagmus, because nystagmus is X-linked recessive. So you should have a dominant allele. So this one is a normal male. What about, let's start first with severe. What will be the allele in the X chromosome of the male to make it severe for the male?
Small n.
All right, so
Small
small
n.
n. And with that, no other choice, no nothing to partner with that because the partner is Y. All you have is a severe nystagmus. But the question is it possible for males to have slight?
No, sir.
All right, because you could only get just one more X chromosome. And it could either be a capital N, you're normal, or a small n, you have severe nystagmus. So slight will be out of the question for the males. The males can either be just normal or severe. But for the females, what will be the genotype of a normal female?
Capital N, capital N.
So both X chromosomes containing both capital N's. What about a female with a slight nystagmus?
Capital N and small n, sir.
All right, so there is now possibility of pairing with another X, but this time carrying a small n allele. And severe,
All small
Small
n,
n,
sir.
small n, sir.
all right, both of you are correct. So small n and then small n. Okay, so I'll only go up to that, and then I think you can already analyze A, B, and C. Any questions about this? So this is X-linked, no, or sex-linked trait. Any questions? This is similar to hemophilia, also color blindness in humans, which is also X-linked. I hope that clarifies things. So let's move on. We have little time left. The color of fur in cats is controlled by a pair of X-linked alleles. So X-linked na naman. Yellow is incompletely dominant over black. The heterozygote is calico or tortoise shell. So here we have to just look at the X chromosomes or the sex chromosomes. So for females, you have this. For males, of course, you have X and Y. And the color of fur is controlled by a pair of X-linked alleles. Yellow is incompletely dominant over black. Meaning to say a female will only be yellow if what will be attached to the X chromosomes for females? Yellow. Start first with yellow. You can use any letter, but you can use Y, of course. You can use B for black. So what will I attach here on top for the females na X-linked trait?
Why, sir?
All right. So, okay. So Y and Y. You cannot have another allele. Otherwise, they will sort of mix because of the incomplete dominance stated. Okay. What about for the male cat here on the right? What could be attached on the X chromosome to make it a yellow male cat?
Why, sir?
Also a Y, and there's no partner, so there's no problem. There's only Y, one X chromosome with a Y. Now, what about a black cat? What would you expect in the X chromosomes of a female?
BB.
All right, so you have B for black, and for the male, what will be in the X chromosome?
Bira, sir.
Okay, so just B. All right. And what about there's a heterozygote condition. We call it the calico or the tortoise shell. So ito yung mga cats na maraming colors sort of mixed together, no? So let's just call it a calico for this. What will be the female's genotype if it's calico?
Y and B, sir.
All right. So Y and B paired together. Is it possible for a male to be calico?
No.
No. Okay. So, guys, if you see a cat, tapos tortoise shell ang kulay ng cat, no, parang mix, parang kabang, or not really kabang, but if you look at the color of the cat, it's tortoise shell. You know what I mean? It's a female. It's impossible for a cat to be like that. And then it's a male. Okay, so no males are calicos or tortoise shells. I leave letter A for you since I already gave this hints. Let's move on. Number 8. Hypertrichosis of the ears is caused by a Hollandric gene. We need to understand what this means. What does Hollandric gene mean?
Y-link.
All right. So if there's an X link, like our examples a while ago, there's also Y link. And we call it, another term for that is Hollandric. No? Holy in males, andric. So hypertrichosis is Hollandric. In humans, baldness is dominant in males. So you might have a male and then a female. So in terms of baldness, guys, baldness is dominant in males and recessive in females. Meaning to say, let's have a simple symbol for baldness. We can have a big B for males, okay? And then a big B here, for example, for females. Will the male here be bald or not?
Yes,
Bald,
sir.
sir.
Bald, okay. So this one's bald. What about for the female? Baldness is recessive in females.
Dili siya
No, sir.
bald, sir.
Okay, so no, not bald. What about a big B, small b? Big B, small b. For the male,
The male will also be bald, sir.
okay, also bald. What about for the female?
Not bald. Not
Okay,
bald.
not bald, that's correct. What about small b? For the male,
Not bald, sir.
all right, not bald, but for the female, because baldness is recessive,
Bald siya, sir.
okay, so this is the only time the female will be bald. Okay, and then there's hypertrichosis, which is Hollandric, so only the males can carry a Y. So it's only true for males. Now it's impossible for females to be to contain or to carry that gene because they cannot have a Y chromosome. So here's the first question: can a normal non-bald daughter? So where's the non-bald? So this normal non-bald daughter have a hypertrichotic bald father. So meaning to say, bald na tapos may hypertrichotic gene pa. Is this possible? Na the daughter is like this and the father is like this. Yes or no?
Yes, sir, because hypertrichosis is only carried by the Y chromosome, sir.
Yes. And of course, his daughter will not get the Y. So that's one down. Correct. What about the baldness? So this father can give this capital B paired with another capital B from the mother to get this. Or this father could give the small b in this case paired with the capital B from the mother, get having this, or the other way around. No? So the answer in letter A is yes, based solely on that reason. Okay, so let's move on. Okay, next, red-green color blindness in man is recessive and X-linked. So X-linked, recessive. Let's just have a small r, red-green color blindness. Migraine is dominant to the normal condition. Oh, so meaning to say capital M, capital M, capital M, small m. Okay, both of these have migraine. Well, this one's normal. Okay. A colorblind woman, okay? How will you make a colorblind woman? What will be the X chromosome of the colorblind woman? We are now here. A colorblind woman. Let's analyze this. Because color blindness is recessive and
Small
X-linked.
r, small r,
All
small r.
right. So the woman will contain X chromosomes with the recessive alleles for both. Okay? So a colorblind woman who is otherwise normal. What's normal in terms of migraine? What will be her pair of alleles for migraine?
Small m, sir.
Okay, so this is the woman. Okay, is married to a man, so at times married to a man with migraine. So parang binaliktad lang ng statement, pero migraine tayo mag-start. The man has migraine, meaning to say the man could either be
Ones are either big M, or big M, small m.
okay, so or yan o or and then normal, meaning to say the man is not color blind. So what is the X chromosome of the man?
Capital R.
Capital R. Okay, so there. But meron pa palang information that we forgot so that we can reduce this big M, big M, big M, small m. The man's father is normal for both traits. So which one will be the man's genotype for migraine? Normal man ang father niya. And normal is small m, small m.
Big M, small m siya, sir.
All right, so the father, therefore, will have this. Okay, so cross these. No? And then you may now answer question A. Can this couple have a normal visioned son or a normal visioned daughter? So I will not answer that one for you, but this one is already going to bring you halfway through the item. Okay. So I left number 10. I will leave it undiscussed. So that's up to you, the one with the Z chromosomes. Okay, but I hope the discussion was helpful. All right. So we're pressed for time, so I'll continue. Homework number 4, the one that we just discussed, is due midnight today. So you can still edit if you want to. Due midnight today. The quiz on chapter 3, which is more Mendelian genetics, no, still chapter 3, is now open. It was opened 7 a.m. It will close 8 p.m. tonight. So you do your priorities. You can perhaps do your quiz first, and then 8 p.m. to 12 midnight, you finish your homework number 4 before you pass it. Okay? So that's today, Wednesday. So are there any concerns or questions? I will be posting the answers, of course, tomorrow na, no? After everyone has passed their homework. And for homework number 5, we will not be able to have a discussion on it like this because there's already an exam week, no, next week. Instead, I will just be sending again my answers to homework number 5, but you have to be able to analyze that yourselves na. So any questions or concerns?
Regarding the midterms, sir, more on kuhan siya, sir, solving.
Definitely there will be solving. I believe it's going to be multiple choice still, even if there's solving. And then there will also be concept related na hindi solving, no, related.
Okay, sir. Thank you, sir.
All right, any other questions, clarifications, concerns? Okay, I hope I didn't keep you from your next appointment. We're 4 minutes, 4 minutes extended already. So allow me to just tell you to ask me questions through eLearn or through Messenger if you have any more questions. And thank you guys for joining me in this video teleconference. I really appreciate it. And it's fulfilling for me to discuss with you the answers as well than just giving you the answers and the pictures. So have a productive day ahead. You have a lot of things to do ahead in terms of our subject. All right. So thank you guys, and you are now all dismissed.
Thank you, sir.
Bye,
Thank you, sir.
sir.
Thank you, sir.
Bye,
Bye.
sir.
Thank you, sir.